this term here. So we start from here. We are given this one. I simply put into this form. Okay, so yeah, that should be right? Okay, help me. That's right. Yeah, I commonly make mistake. If I would take the same test with you, yeah, many of you can be doing better than I, and because I'm simply not good in taking tests, to be honest with you. Okay. So now for the first one, and using these particular examples, and to utilize the tables here, we have to show something, do some algebraic operations such that the information can appear on the tables. And most of things, and later on I'm going to show with more other example is, we split, we factorize because into the terms here. Because it's factorized by, it's multiplied in denominator by the 3 terms, so I'm going to do the reverse. So we split into the 3 terms. In terms of this, the summation of the 3 terms, okay, and this one, the highest order is 1 degree. So here, the unknown coefficient in the numerator should be 1 degree lower than the numerator denominators. So let me call this ABC. Again, I do this because for one purpose, I want to have some terms showing up which are available from the tables here. And to do this, I simply observe the denominator, which for this case is the multiplication of 3 terms. So I split that multiplication into the summation of certain terms. And once we determine the numerator here, then once we determine the denominator, numerator is a polynomial that is 1 degree lower than the denominator. So here is 1 degree, so this should be 0 degree, which is constant. Okay, so now we have to define the ABC. So how to calculate ABC? So to determine A, B, C, then that is very straightforward. We simply compare the 2 terms, term by term. So basically here you can see, let me pre-multiply it again. S plus 1, S plus 2. So A times S plus 1, S plus 2, plus B, S plus 2, and plus C, S plus 1. I simply do the things together and then I compare both terms, right? So in this way, the numerator and the denominator have the same, and I simply compare the numerators. So compare the numerators. So numerator is the polynomial of the second degrees, so S squared and S1 and S0. From this term, the coefficient of S squared equal to 1. From this term, the coefficient of S1 equal to 3. From here, that coefficient equal to 1. Okay, on this side, the square term equal to, if you expanded this one, that will contribute A to the S squared term. You expand this one, that will contribute the B. If you expand this one, that will be the C. Be good? For S, the linear term, so if you do this carefully, and that will contribute 3A. For this term, that is 2B. For this term, that is C. Good? Okay, now for the constant term, this one multiply is 2A. For this term, is 0. For this one, 0. So therefore, from here we can determine A equal to 1 over half. So once you have the A solved, and from here you can determine BC. Believe me or not, you can help me calculate this one. Okay. How about trust me one more time with this number? So basically here we have the here determined S and A equal to 0.5, and then plus B as 1, B equal to 1, and plus S2, and that is minus 0.5 here. Okay. So now, yes.
Those ABC correspond to the steady state. Is that right?
Yes. Yeah. So right now this is the capital X. So therefore X over T steady state equal to the inverse of capital X. So right now I want to take the inverse of individual terms. 0.5 S plus Laplace inverse of 1 S plus 1 plus Laplace inverse minus 0.5 and S plus 2. Okay. So right now we begin to apply. You can see for this term where that appear here, 1 over S that appear, but here it has a coefficient. So we combine it with this term here. So again, for individual terms, assuming G is 0, so whatever we scaled in the time domain, the same scaling applies to the S domain. So we take this pattern. This pattern right now for the first term is 0.5 multiplied with this one. So basically it's 0.5 with constant. 0.5 multiplied with the plus inverse of 1 over S is constant 1. So basically that is constant 1. Be good? Okay, now the second one is the plus inverse of S plus 1. Where is S plus 1? This one. This pattern. When A equal to minus 1, that is our example there. So corresponding is E, AT, A equal to minus 1, so E minus T. Good? And the last one, again, the last one is minus 0.5, and let me rewrite one more time, and S plus 2. Okay, basically this, I take the scaling factors, the coefficient out of the operation, that won't change. So then for this one, you see that one we take out this pattern when A equal to minus 2. You good? Okay, so that corresponding is minus 5 times this one. So basically that is this term here. You good? Okay, so so that meaning I would say this one, if you want to have a cheat sheet, and this must be on your cheat sheet. Okay, you can copy and paste, or you can rewrite on your own words. Okay, basically the information here have 3 columns, and for each column, the one side is time domain, and the other side is the corresponding S domain. So probably today we stop here. Then coming, then we will have more exercise, and then try to gradually get into the our